Good evening. I'm Jennifer Lynn Bartlett, President of the Friends of Arlington's David M. Brown Planetarium. Thank you for being with us this evening. We are still bringing you community science-themed programs, even though our planetarium is temporarily closed due to construction. In addition to online talks like this evening's presentation, we anticipate an increasing number of in-person events, such as the upcoming vernal equinox bike ride. So please follow us on our website or join or renew your membership to get our email messages of programming opportunities. And we should have an increasing number of activities this summer, leading up to when we hope the planetarium will open in time for the new academic year. Tonight, I am pleased to have with me Professor Patrick Seitzer, who is a research professor emeritus at the University of Michigan in Ann Arbor. Recently, his research has been in space situational awareness, which is kind of a fancy term for keeping track of the things that are in orbit around our Earth. His doctorate in astronomy is from the University of Virginia. He has a bachelor's in physics from Georgetown University, and he has lived and worked all around the world in the course of his career, including growing up in Arlington, Virginia, our hometown. So he and I share a connection through the University of Virginia Department of Astronomy, and growing up here in Arlington, and a passion for the history of astronomy. But tonight he is here to talk to us about space situational awareness, or specifically when good satellites go bad, the problem of space debris. Dr. Seitzer?
All right, thank you very much for the introduction, and let's get started. So I'm going to, can you see my, the first slide in my presentation?
I can.
Okay, excellent. So I'd like to thank Jennifer and Kathy for giving me this opportunity to talk to you. As Jennifer pointed out, I grew up all over the world. I came from a military family, born in Japan, grew up in Germany, lived all over the US, but finally settled in Arlington before I took off on an astronomical career, which took me to Australia, Chile, many places in the US. So anyway, tonight I'm going to talk to you about a problem that's been with us for a large number of years, but you may not have heard of it. And it's a problem of when good satellites go bad, the problem of space debris. And the topics I'll talk to you about tonight are two different but sort of related ones. What is orbital or space debris, and why do we care? And the second thing is the problem of bright satellites in astronomy, or why you should go see the dark skies now, soon, before there are many, many more satellites launched. So let me start with this, a tour of our solar system. And I hope all of you have had a chance to see this magnificent planet, which is Saturn, and its ring system, hopefully through a small telescope, or certainly the images that have been returned from Hubble like this. So this is just one of the many planets in our solar system that have a ring system. This is one. Here's another one. This is Jupiter, which has a very small, narrow ring. Not very tough to detect from Earth, but detected from spacecraft. Here's another planet. This is Uranus with its ring system and numerous satellites. And two more planets to consider. This is Neptune, which in this image, which has the central part is blocked out because the planet is so bright, but you can see the various ring systems around the planet Neptune. Well, the final planet I will take you to is this one, which also has a ring system. And here we're looking straight down on the North Pole of that planet. And this is, of course, the planet Earth. And the ring system that you're seeing here is the geosynchronous belt, okay, where there's located satellites that have the same orbital period as the period of the Earth goes around on its axis. So they appear motionless above you. And if you had a small satellite dish that you see more and more of, they're pointing at one of those satellites. Here's another view of the same thing. Again, You can see the ring system out here. Those are active satellites. When they run out of fuel, though, they start to maneuver and they start to go up and down 15 degrees above and below that plane. You can also see everything around the center of the image, and that's Earth. That's the center part of Earth. And this image is a couple of years old, but there's over 10,000 objects now in orbit around in low Earth orbit, less than 2,000 kilometers, probably more than 15,000 at this point. And most of those are inactive objects. There's only about 5,000 active satellites around the planet now. Everything else is junk. Okay, it's dead rocket bodies, various pieces. Let me just define what is space and orbital debris. Okay, it can be spacecraft no longer active. So when your weather satellite or your communications satellite runs out of fuel or has completed its mission or dies, has a failure on board, it becomes space or orbital debris. It can be rocket bodies. Once the rocket body has been used, the final stage to put the satellite in orbit, the rocket body is of no use anymore. It's just dead. It's like a junked car on the side of the highway. You can have parts of spacecraft and rockets from fragmentation or breakup events. So if the fuel or a battery on board a rocket blows up and throws all sorts of parts in orbit, that's what's known as a fragmentation or a breakup event. And finally, you're going to have just junk, aperture covers, astronaut toolkits. Occasionally, the astronauts drop or let loose a tool or a toolkit, and it's floating in orbit before it re-enters. Solid motor fuel, gloves, you name it. Anything that's not an active satellite currently performing a mission. And this plot here is rather complicated, but it starts back in 1957, okay, when Sputnik 1 was launched. And there were 2 satellites in the initial catalog of objects on orbit. There were 2 objects. There was Sputnik 1, and there was the rocket body. So in the initial catalog of everything that was on orbit at that time, the debris population was 50% of the total population. 2 objects, 1/2 was debris, 1/2 was a satellite. And the situation has only gotten better or worse, depending on your point of view, since then. And so as we go through the years here, we can see this is the total number of objects larger than 10 centimeters that the US Air Force tracks. That's from the public catalog. And right now we're closing on 26,000 objects in orbit. But the true number is much larger than that. And the true number of objects smaller than 10 centimeters is unknown, but several million. So if I look here, you'll see these sudden blips, these sudden increases. In 2007, it was a Chinese Fengyong 1C anti-satellite test. Okay, ASAT refers to anti-satellite, where 2 satellites were deliberately collided together to destroy them. And that released a whole bunch of debris, over 3,000 pieces. In the second one we're going to look at is Iridium Cosmos back in 2009. This was completely unexpected, where an active Iridium satellite, and this is a communication satellite. If you have one of the handheld Iridium phones that talk through a satellite, there were 66 of them in orbit, and it collided with a dead Soviet communication satellite. It was unexpected, and that produced another couple thousand more pieces of debris. More recently, item 3 here was the deliberate destruction by the Russians of a Cosmos satellite, a dead Cosmos satellite, back in November of last year. And that produced a couple of thousand more pieces. There's at least 1,500 which are being tracked. These are bad moves. You don't want this to happen. But you'll see that the total curve, with the exception here, the curve goes down a little bit, which is due to atmospheric drag. The satellites experience a little bit of drag due to the atmosphere, and then they re-enter and burn up in the atmosphere. So that's good for us. What you also see here is that the satellite population, whoops, let me go back one here too quickly. The satellite population is also increasing, perhaps not as fast as the debris population, but this population of active satellites is dominated by SpaceX and the launch of their Starlink satellite constellation. They have launched over 2,000 satellites into orbit already, all in low Earth orbit, less than around 550 kilometers. And they're launching more literally every week. And that population will grow to just over 4,000 satellites when the constellation is complete. But they've also put in for permission to launch another 30,000 satellites for a total of 34,000 satellites in orbit. And so this curve here is starting to go vertical, mostly because of the launch of new satellites, but also because of some debris events. Now, I have to be careful here because even as I'm giving this talk, there could very well be a debris generating event on orbit, and this curve could be out of date immediately. So, but what I want you to take away from this is when you look up in the night sky, you're looking through the world's largest junkyard. And I will come back to that in a minute. So this shows you the orbits of this is a graph here. This here is the Cosmos 1408. This is the satellite. These are all the debris that have been generated from it. Most of it's in a plane, but some of it's in it plus or minus a couple of thousand kilometers from that plane. These are the orbits of two of the most famous objects in low Earth orbit: the Hubble Space Telescope, which is still working, thank you, and the International Space Station, which is still working, and the astronauts on board certainly are very grateful for that to happen. But you can see that we're starting to fill in, and life is getting more and more crowded in low Earth orbit. So just to show you that spacecraft are not immune from impacts, that space debris can affect existing spacecraft. This is one spacecraft that was visited by the astronauts in 2002. And on one particular surface, they counted the number of impacts that they saw. 1, 2, 3. And those are the ones that they saw in 2002. The spacecraft was visited again in 2009. And you saw all these other craters that had been added in the 7 years since. The green circles was what the astronauts counted in 2009. Well, this was the Hubble Space Telescope, and this was the camera radiator, the wide field planetary camera, which took some of the most spectacular images that you have seen of the universe. And it was constantly getting bombarded by space debris or by micrometeorites. And how do you tell the difference? Well, you look in the center of the crater, and if there's titanium in the crater, then that's obviously come from orbital debris. If there's no titanium, it's probably a micrometeorite, since no one knows how to create titanium paint on natural meteorites. Here's some more examples from the Hubble Space Telescope antenna. A debris impact here. Okay. These are all impacts on one of the surfaces of a Hubble Space Telescope. And these are counted, pictures are taken, and they count, and they get the rate as a function of size. Here's the astronauts were out working on the telescope, and they found this impact on it as well. And obviously, this looks like impact number 156. So you can see that the numbers are getting bigger and bigger. So anyway, space debris is an increasing problem on orbit. There's more and more being generated every day. And you're basically working in the world's largest junkyard. And the concern is now that there are tens of thousands more satellites being planned. There's at least 100,000 new satellites being planned over the next decade that will go into low Earth orbit. Some people have filed for 300,000 satellites in one particular constellation, and we don't know if that's for real or if it's just an attempt to grab space and lock in the regime. But it's going to get worse as these satellites collide, as some of them are hit by debris and become inactive. then the problem of space debris or orbital debris is very, very real. And it's one of the most important issues in space flight right now. So, how can you control space debris?
Pardon me, Pat. We
Yeah.
have a question.
Okay.
Have there already been any satellites lost to accidental space debris collision?
No, there have been no. Yes, the Iridium satellite was lost. That became back in 2000. In 2009, that satellite was totally destroyed. Well, I mean, not totally destroyed, but it became inactive. There have been a couple of other satellites, active satellites, that have been damaged, but not taken out of commission. So it's probably fewer than 6 satellites that have been damaged. And the only one I know of that's been totally destroyed is the Iridium satellite that was destroyed in the Iridium Cosmos collision. The Cosmos satellite was inactive, it was already dead.
One more question.
Sure.
Do not most satellites have programming that at the end of their life cycle, they move into the atmosphere and completely burn up?
I'll answer that in a moment. Some do, but some don't. So, and let me answer that question here in a moment when I get through how to control space debris.
Okay, thank you.
Any other questions at the moment?
That's what's come in. Thank you.
All right. So, how do you control space debris? Well, you plan carefully. You don't create on launch. For example, if you're doing a space telescope, and there have been space telescopes that do this, you typically have an aperture cover that covers the telescope when you launch. You get into space and you eject the aperture cover like a frisbee flying off into space. Well, we sort of just, we don't like that to happen now. And Hubble, the aperture cover is kept on the spacecraft, but you try to create the minimum amount of space debris that you can when you launch and deploy a satellite. You can deorbit a spacecraft at the end of the mission. And there are 2 ways that can happen. It can be natural decay due to atmospheric drag, which will be 5 years at around 450 kilometers altitude, or you can deliberately deorbit it, as the questioner asked. Not all satellites have artificial deorbit capability. The natural decay due to atmospheric drag becomes extremely long the higher altitude you are. So if you have a satellite at 1,200 kilometers altitude, then that can last for centuries, many, many centuries before it decays. Okay, so the decay is 5 years at, say, 450, but that depends tremendously on what the atmospheric density here is. And there have been some recent studies which are showing that our friend climate change is actually making the space debris problem worse, because the heat gets trapped in the lower part of the atmosphere, and the upper atmosphere of the satellites in low Earth orbit is not as dense, and so they last longer. Now, the general guideline is that you have to bring your satellite down, dispose of your satellite within 25 years. That's been the rule, but not a law, not an international regulation, just a guideline for the last 25 years or so. So you have 25 years to do something with your satellite. Well, that's kind of nuts. You don't leave an abandoned car on the side of the highway or in an active lane for 25 years. So, yeah, I bet you have another question.
I do. You're mentioning that it's a guideline that satellites, you have to take care of them within 25 years. But who's authorizing these orbits? Who's policing this?
Well, there is that depends very much on the country. And we could go, have an entire half-hour discussion on this. In this country, the Federal Aviation Administration controls licenses the launches. In space debris or orbital debris, which is the US legal term, is controlled by the Federal Communications Commission. So if you want to launch a satellite that's going to talk to or from the US, your radio waves need landing rights. They need a visa, and those visas or landing rights are issued by the Federal Communications Commission. But also, the Federal Communication Commission somehow ended up controlling space debris. And so you have to have a space debris or an orbital debris mitigation plan when you file for frequencies with the FCC. And in general, you follow the 25-year rule there, but most companies are doing it much quicker. For example, SpaceX and the Starlinks, their satellites are now coming down in 4 weeks. 4 weeks, a month, not 5 years, not 25 years. So, do you have any more questions in the queue? Okay.
Then suggested that we wait until the end so that you can proceed in a little bit more orderly path.
No, that's okay. Keep those wonderful questions coming. So it's the
Okay.
FAA which controls launches and the FCC which controls the space debris and the frequency stuff. So there's also active debris removal. And this is where you remove large pieces before they collide and create lots of small pieces. So there's studies now on what the 50 most dangerous spacecraft are in orbit and the particular regions of space which are crowded. And you want to remove large rocket bodies and large dead satellites before they have a chance to collide with other satellites and create lots of small pieces, which can then create even more small pieces when they collide with stuff. And there's a syndrome known as the Kessler syndrome, where eventually you get a runaway debris event. And well, anyway, that's worth another talk entirely. So all I want to conclude here on this is that space debris is a real problem. There's more being created every day. And there are people that just specialize in space debris. And if you read the space newspapers, every day there's an article on space debris and the problem that it is. So at this, I'm going to go to a slightly different topic, which is the problem of bright satellites. But why don't I ask if there are any more questions just on space debris?
Nothing else has come in, but I'll let you know.
Okay, thank you. Is the audio and video okay?
It looks good to me.
Okay. So the next topic we want to talk to you, which is how an astronomer like I got involved in all of this, is that it's a changing night sky. And you're going to see more and more satellites in the night sky. So this is a camera, an all-sky camera by a company called Alcar Systems in France. A beautiful view of the Milky Way here. It's 180 degrees from side to side. This was not taken in a city. This was taken at a quite distant location. There's a few clouds here. But the problem is that we're starting to see more and more satellites in the night sky. So this is the second issue I want to talk about. Modern astronomy has a wide variety of telescope and fields of view. Here's an all-sky camera, which I set up in my driveway and just ran for a few minutes. This is the International Space Station crossing. This is a tumbling rocket body here. So sometimes it's bright and sometimes it's faint. And there's probably, although too faint to be seen here, there's probably somewhere between 500 and 700 satellites in sunlight above me that I could see at this time if my telescope was big enough. So you can start to see that we're starting to see more and more satellites, and the appearance of the night sky is beginning to change. And it's beginning to change from what humans are launching into orbit. Back in May 2019, SpaceX launched its first round of 60 Starlings. And people saw this. These were second magnitude. They were visible from downtown Arlington, Virginia. They were that bright that you'd be able to see them. Let me take a drink of water here. They were just in a temporary parking orbit. At this point, astronomers woke up and realized that people were going to launch maybe more than 100,000 satellites this bright. Would they be visible all night long? Is this the future of the night sky? And the astronomical community panicked. And with good reason, I think they panicked. So here's a view from the Blanco Telescope in Chile. It's a 4-meter telescope on Cerro Tololo in Chile. This is the US National Observatory in Chile. And this is 2 degrees. So it's about 4 times the diameter of the full moon. Oops, let me go back. From one side of these to the other. This is a mosaic camera. So there's over 50 independent CCDs in it. You can't make a giant charge coupled device or a detector this big. So you fill it up with small ones. And this has 19 Starlinks crossing it. This picture was obtained without any planning for whether the Starlinks were going to be in it. But it's a famous photograph now, and the astronomers, of course, panicked as well. It took the satellites less than 4 seconds to cross the field of view. So this was about 1 week after the launch of another generation of Starlinks. So these streaks are going to be a problem for astronomical imaging. Here's another issue. This is a 15-second exposure of an abandoned rocket body in geosynchronous orbit. This one was a very early object launched in 1968. It's tumbling, and you can see these groups of 3 flashes separated by darkness. And so this, in an astronomical image, your astronomical image finding program would think that this was a string of galaxies, edge-on galaxies. And I warn my colleagues not to book their tickets for the Nobel Prize quite yet, but they really ought to look at the image. So when do you see a satellite? Well, you'll see it when the telescope is in darkness, okay, somewhere in here, and the satellite is in sunlight. So you see the satellite off reflected sunlight. So most of the satellites in low Earth orbit, you'll see in twilight, just after evening sunset or just before morning sunrise. And once they go into Earth's shadow, you won't see them. Okay. Now, the poor radio astronomers see them all the time because these things are actively transmitting. And if you're working in the thermal infrared out at 10 microns, you see them all the time anyway, because they're glowing in the dark. So, do we have any questions on this yet, Jennifer?
Yes, sir.
Okay.
Stepping back a minute, what is the plan for the SpaceX satellites at end of life, and how long do we expect these to be up?
Okay, so the SpaceX satellites, the Starlinks now, have a lifetime of 5 years. They all have an active propulsion system on board. And at the end of 5 years, they will be actively deorbited. Okay. And the deorbit time is supposed to be, well, right now they're deorbiting in 4 weeks or so. That's the latest that how fast they can deorbit them. So that's very, very good. SpaceX, I would say, they are the largest operator of active satellites now. About 35%, over a third of the active satellites in Earth orbit come from one company, and that's SpaceX. But they're being very responsible in the sense that they check their satellites out in a low Earth orbit, say around 300 kilometers. So if they fail, then they re-enter very quickly within months. And then they boost them up to their operational orbit at 550 kilometers. So SpaceX has been quite responsive here, and they will bring their satellites down very quickly. If the satellite fails after it's been deployed into orbit, the effect of the atmosphere will still bring it down within 5 years. So that's my answer to that question. Are there any more questions there?
I have 2 more.
Okay.
The first is, our modern way of life depends on satellites, from weather to communications, GPS. How do we continue living in this advanced technological civilization without them? What would be alternatives or solutions?
Well, I think we are probably linked to space in ways that we just don't know. So we could talk about these large constellations. Why don't I delay that question, answering that question, till I show some figures later on? Okay. You said you had one more question. Okay, I'm just going to continue. Well, here, I can answer that question now. So here's an example of both Kuiper and Starlink. Kuiper is being built by Amazon, which will have a few thousand satellites, and Starlink will have about 4,000 satellites in this deployment. And why do you need so many satellites in low Earth orbit? Well, because they pass over you very quickly. like in 5 minutes. At geostationary orbit, they're visible above you all the time because they're not moving. So you need to have a few satellites above you that your antenna can talk to. Why are you building these huge constellations, though, at low Earth orbit? It's actually quicker to transmit a signal to space in low Earth orbit, transmit that to another satellite, and then come down, than it is to transmit via fiber. For long distances, not for short distances, not for the last mile from whatever the ground station is to your house, then it's better to use fiber. But for long distances, the information is transmitted 40% slower in fiber than it is via satellite, just because of the index of refraction of the media that you're transmitting through. And so you transmit stuff, it's quicker to go to space and back down than it is to transmit in fiber, say from North America to South America. So that's why these constellations are being built, to transmit data very, very quickly. So this just shows you Kuiper and Starlink. This shows you OneWeb and Starlink. OneWeb is going to be a polar orbital situation. They were planning to have 648 satellites. They have over 400 in orbit now, but their launch site was from the Soyuz base in Russia, and their launches have been called off and their satellites have been seized. So we don't know when the OneWeb constellation will be finished. They're a polar constellation. The OneWeb, the Starlink constellations have an inclination of 53 degrees, so you never get any coverage at the poles for them. So anyway, how do bright satellites affect observations on telescopes? Well, a bright satellite streak can saturate the detector. So if I do a cross across this very bright satellite streak here, let's go back, it's flat topped. You can think of the detector, each element of the detector is like a pail. And once the pail overflows with water, it can't hold any more electrons, which are produced when light falls on it. So you lose information. This one has a fainter streak. This is a bright Atlas rocket booster, and this was a Cosmos object. Both they've taken at very different times. These are one CCD from that collection of 50 odd CCDs that I showed you before. So you have loss of information in the pixel elements, you have crosstalk in electronics, you have ghost images, you have possible residual images. The problem goes on and on. So we really want to minimize the number of bright streaks that appear in our images. Let's look at what's in Earth orbit today. You've seen this plot before. What we're interested in, what astronomers are interested in, we don't care if it's a rocket body or a Starlink or space debris. What we care is the top curve, the number of objects in orbit, because any object in Earth orbit that reflects sunlight is of concern. The top curve concerns astronomers and space safety experts, because it's the total number of objects that you worry about. And this is the public object catalog of objects maintained by the Air Force for objects which are larger than 10 centimeters, but the catalog is incomplete because the tracking things are incomplete and not perfect. So if I look at this catalog and run it through a prediction program, I can ask how many objects are visible at night in springtime at, say, Cerro Tololo in Chile. And so this is the objects greater than 30 degrees, get more than 30 degrees above the horizon. This is the start of the darkest part of the night, and this is the end of it. And sunset is over here, and sunrise is over here. And even in the middle of the night, okay, the darkest part of the night, local midnight, there's still 600 to 700 objects above you in sunlight that you might be able to see if you had a large enough telescope. So what you're looking at is you're looking through the world's largest junkyard when you look at through the stars. Those beautiful shots of stars and galaxies and stuff, there's all sorts of junk between you and them. Sorry. And if I was to take this elevation down to the horizon, it would probably be 3 times as great. So there's probably well over 2,000 objects above you at any one time. The new large constellations, if we have 600 to 700 objects now visible at any time during the night, why do we care? Brightness. The new satellites could be brighter than most objects in orbit now. SpaceX alone has added another 2,000 bright satellites in the last 2 years. They are launching every week or every other week. They do more launches than anyone else on the planet. So here's a sample constellation which shows you how the altitude varies, or how we really want satellites to be at low Earth orbit. So suppose I took the same constellation of, let me go back here one, of 10,000 satellites. You have 100 planes with 100 satellites per plane. Inclination is 53 degrees. If they're at low elevation, low altitude, 500 kilometers, then in the middle of the night, there are no satellites visible, okay? Because they're in the Earth's shadow, and the Earth's shadow is a cone, not a cylinder. But if I was to launch them at 1,000 kilometers, then there are satellites visible even in the darkest part of the night. So we really encourage the operators to launch low. Don't go into high altitude systems because they're visible longer into the middle of the night. And for space safety, it's also better to launch lower, because if you launch lower and your satellite fails, the atmospheric drag will bring it down quicker than it would be at 1,000 kilometers. 500 kilometers, maybe less than 10 years. 1,000 kilometers, many, many centuries before it naturally deorbits. So here's what Starlink has done to try to reduce their brightness effects. They put visors, essentially sun visors, on their satellites to block the sun from getting to the antennas. It was the antennas that were the bright things. They also, and the Starlink satellites are really clever, they change shape during the mission. So right after they're launched, they're a flat surface like this, called an open book configuration. And they fly them so that they're edge on to us, so you don't see them. Okay, they're very, very faint. When they reach operational altitude, they go to something like this, a shark fin configuration. And then they can be brighter, but they put visors on the side of the satellite that faces the Earth. And that cuts out much of the brightness of the satellite. That alone made them 4 times fainter. Oops, too much going on here. So this is a technical plot, but this is from a Russian MMT9 observatory, an automated observatory. And it ranges from 4th magnitude, which is bright, all the way to 7.5 magnitude, which is faint. And these are astronomical units. When they started launching, their median V magnitude was 5th. And so you'd be able to see these satellites from the suburbs, the distant suburbs of Washington, D.C. Now they're 6.5. Okay, so they are much, much fainter. The goal is to make them 7th magnitude. Okay, if they're 7th magnitude at any point in their orbit, they will be invisible to the human eye for almost everybody, but from a real dark sky site with no moon. Okay, so they've got about half a magnitude, maybe 40% to go before they reach that goal. But they've already cut them back a factor of 4. And that was in response to the astronomers' complaints and all the bad press they were getting. So, I have to salute SpaceX and the Starlink project for all of the efforts that they have put in. There will always be somebody who is blessed with exquisite night vision who will be able to see them, even at 7th magnitude. That won't be me, and I predict it won't be most of you either. So there have been some conferences on this, and here are 2 of the first ones that happened, Satcon 1 and Dark and Quiet Skies. And the recommendations were keep satellites fainter than 7th magnitude at all times and fly low, 600 kilometers or lower, so that they're not visible in the middle of the night. They are in the shadow of the Earth, and they're not illuminated by reflected sunlight. So where do we go from here? Where can you see satellites? Well, there's a website called heavens-above.com. If you enter in your location up here, it'll give you predictions of Starlinks and various other things. The International Space Station, ISS, you'll be able to see from Arlington. I predict you won't be able to see most of the Starlinks from Arlington because the sky is too bright, even if you have a power failure. Hubble Space Telescope, you should be able to see. NVSat is a large European Earth environment study satellite which failed. And it's now tumbling in low Earth orbit. And it's one of the objects that people are most concerned. Can they remove it from orbit before it becomes, collides with something else? Or it re-enters the Earth's atmosphere and survives all the way down. So there's so many dangers from space debris that I haven't even begun to talk about. One of them is re-entry, and you want the satellites to burn up completely in the atmosphere. Because occasionally they come down and parts are recovered. And that you don't want to happen. You want to make sure that they burn up completely in the Earth's atmosphere in a program called D4D, Design for Demise. But there's an environmental impact on that as well. So what happens if you have 10,000 satellites a year burning up in the Earth's atmosphere? What happens to that material as it floats in the upper atmosphere? We could go on for hours. So these are the reports. So I'm just going to conclude with this slide. Go see the dark night sky now. I can't emphasize this enough. Go see the dark night sky now. I've been studying it. I've been going to Chile for 40 years. It never gets old to sit out there under a dark sky when there's no moon. You're away from city lights. You can see the Milky Way. You can see thousands of stars. And count the number of satellites that you see in evening or morning twilight. Just count them. And I predict when you go back in 5 years and do it again, or the next year, you'll see many more. Most of those that you see will be close to the horizon, okay, just because of the geometry of the situation. So look for most of them lower than 30 degrees, but there will be a few floating up here as well. And with that, and remember that when you're looking through this, when you see this magnificent galaxy and these magnificent stars, you're looking through the world's largest junkyard with at least 40,000 pieces of large space debris, larger than 10 centimeters, the size of a softball, and many millions of pieces down to the size of paint flecks. So with that optimistic note, I will close. And if there are any more questions, I'm happy to take them.
Thank you. I have a few questions. And if there's anyone out there who has not typed their question into the chat, please do so. I'm sure Dr. Seitzer would be delighted to take all of the questions that people are willing to throw at him. But first, you have said some things about this as you go along, but if you could recap, what, if any, steps are the satellite owners taking to minimize lighting and space junk as a problem?
Okay, so all of the major satellite operators are now aware of the problems that bright satellites cause for astronomy. So that's the first issue. SpaceX has taken, really active measures to try to make their satellites as dark as possible. And that comes from Elon Musk himself. And Elon said, solve this problem. And I was on a telecon where he said that. And so they are putting a lot of effort into this. And they don't have to. There's no regulation or law or guideline on the brightness of satellites. Okay, the FCC doesn't care how bright satellites are. They have no legal authority to regulate the brightness. The other large constellation and operators like Amazon will launch 2 experimental satellites of different design this year. And they have asked astronomers to measure the brightness of those satellites so they can compare how well their brightness mitigation efforts are going to be. The big 3 operators like SpaceX, OneWeb, Amazon Kuiper are involved in every one of these conferences. Okay, so there is industry participation in every one of these conferences. And I think we're very pleased by the effort that at least those big 3 companies are taking to mitigate the problem of bright satellites. Um, I think I answered the first part of the question. Can you remind me what second question was?
What
Oh,
about
what
space
had
debris in the junk?
to do with space debris. So the SpaceX satellites can maneuver. They get uploaded what are called conjunction data messages from the Air Force. And so they can maneuver to avoid collision, which is good. And that avoids space debris. And then they will be re-entered at the end of mission and burn up in the Earth's atmosphere. So they will not be left up there for 5 years or 25 years. I assume Amazon is going to do the same. They were certainly in the studies I saw a few years ago said they would re-enter within a year. OneWeb, though, has a problem. If one of their satellites failed, and one out of about 400 that they've launched has failed, it's centuries for it to come back down to re-enter without, if they lose their propulsion system. So they're talking with active debris removal companies to try to go up and get it and bring it down. But they also will try to have their satellites re-enter quickly, certainly within 5 years. I think I answered that question.
Thank you very much. And I'm working my way through the other questions. Please continue to put them in the chat and we will get to you. You mentioned a preference from an astronomer's point of view that the satellites be, these large constellations, be in low Earth orbit. But why would Starlink, et cetera, not wish to be in geosynchronous orbit?
Why wouldn't you put everything in geosynchronous orbit? The delay time. Okay. It takes longer to go. Geosynchronous orbit is at an altitude of 35,786 compared to an altitude of 550 for the Starlinks and just over 600 for Amazon and 1,200. So it's much quicker to go to low Earth orbit. And if you're worried about latency, you're playing video games or doing rapid financial information transfers, the latency, the delay time becomes important. So it's something like a quarter of a second to go to geo and back, and it's less than a tenth of a second to go to LEO and back. So it's much quicker to go to low Earth orbit and return than it is to go to geo and back. It all has to do with the latency or the delay time.
Okay. What are the realistic plans for capturing and deorbiting or otherwise cleaning up the debris from low Earth orbit?
What are the plans for active debris removal? Everybody and their uncle is working on active debris removal right now. The Air Force has declared it a major, or Space Command, Space Force has declared it to be an area of major interest. There's any number of companies in the US that are working on it on plans to go up and grab a satellite and maneuver it so it re-enters quickly. There's a company in Japan which is testing technologies. Companies in Europe are doing the same thing. No one has demonstrated it yet. NVSat, the big European payload, is still there, but everybody is working on it. Okay, it's going to be expensive. It's not going to be cheap to do a launch and intercept something the size of a city bus, which is probably tumbling, may have rocket fuel still on it. You want to capture that without causing any more space debris, stabilize it, and cause it to re-enter into the Earth's atmosphere to burn up. Or if it's going to survive all the way down, you would like a controlled re-entry into the southwest Pacific to a point called Point Nemo, which is the point most distance from all land. And when big objects such as the former Soviet space station and hopefully International Space Station, when it re-enters, they will do a controlled re-entry and try to cause it to re-enter into Point Nemo into the South Pacific. So it's far away from any land whatsoever. Let me.
Okay.
Go ahead. I'm going to stop sharing here for a moment. Can I see the? I guess I can't see the. Oh, I can see them.
Okay, I've worked through most of the questions that we've received so far. Are there any others that people want to type in, please do so. I'll give it another minute to collect those. In the meantime, you've been talking about controlled deorbit. What are the risks of the things that are uncontrolled falling out of the sky?
What are the risks of the uncontrolled things? Well, about once a month, something uncontrolled big re-enters the Earth's atmosphere. And sometimes debris makes it all the way down to the surface of the planet. Since 70% of the surface is water, your risk is reduced considerably. But there's still a lot of area where something could come down and hit. The SpaceX rockets, the final stages, are supposed to do a controlled reentry, but there's been one failure so far, and it re-entered over Washington State. And but no, it's a good question. About once a month, something large comes back down.
You mentioned that the Federal Communications Commission controls launch or permissions for the U.S. and space debris. Can you give a brief summary of what other nations, what their controls are?
Well, can I talk about what other nations are doing? No, I really don't know. For example, in Europe, there is the European Space Agency, and which is many European countries working together for to explore space. They have their own space debris office, and they're very, very attentive to the space debris problem. So certainly they do their part, on a big part, on controlling space debris. But I don't know what the regulatory environment in Europe is, and or elsewhere. There's concern that there's concern about space debris everywhere, internationally. But I don't know what the laws and regulations are in Japan, for example, or in Russia, or in China, or New Zealand, which has a launch facility now. So, I don't know the answer to that question.
Fair enough. How do we identify and track space debris?
How do you identify and track space debris? You can either do it optically with telescopes, or you do it with radars. And the radars have an advantage in low Earth orbit because you can track them almost 24 hours a day, except for a small region when they're close to the sun. So you don't care if they're in Earth's shadow or not, because the radars have their own illumination. And the same thing during daylight, when the sky is too bright for you to see anything, the radars can work. So in low Earth orbit, the radars are the preferred manner to do it.
And you mentioned public catalogs. Can anyone access those?
Yep, you sure can. The official public catalog is available at let's see, I guess I can't see anything, is a site called space-track.org, space-track.org. And it's the front face of the U.S. Air Force. Got it. Space.track.org. There it is. And in the chat, and you can sign up for a free account there and go through and download the public catalog of orbits, which is updated on a regular basis. And there's all sorts of plots and stuff that you can find there as well, which shows you how many launches per year. And they send out alerts if something's happening in Earth orbit. There's another public website which is run by, it's called celestrack.com, CELESTRAK.com. And it has some beautiful visualization tools and stuff that you can use. And there's also one at the University of Texas in Austin, which has some beautiful visualization tools as well. So.
All right, I think the last question that has come in is, do you study Earth-crossing asteroids as well?
No, I don't. I do not study Earth-crossing asteroids. That's an entirely separate study, but one that's extremely valuable because we don't want to go the way of the dinosaurs created by having a major asteroid impact the planet, or even a small asteroid impact the planet. So that's an entirely separate thing. The time scales are different. Where you look in the sky is different as well. Well, I just work on the artificial stuff that's polluting our night sky.
We will have to put that on our list and try and get a speaker on that specific topic, because I think it is also a fascinating subject and one in which many people may be interested in. I am not seeing any more comments coming in, so I am going to wrap up unless there's something else you want to tell us.
No, thank you for the privilege of talking to you. And I hope you learned something. And again, I emphasize, if you haven't been to a dark sky site, get to one as soon as possible. Southwest US is a great place when the moon is down, new moon. Also look in Chile, in Australia, and Southern Africa, in the Kalahari Desert, Namibia. There are some fantastic places to see. Obviously, I'm biased toward the Southern Hemisphere, which is where I spent most of my professional career. But go to a dark sky site. There was an article at the end of February in the Washington Post about 6 dark sky sites near Washington, D.C. I think I still have that bookmark somewhere, and I'll send Jennifer the links on that, and the links on a couple of others, and she can send them around to people that are interested. So, but go take a look. Take your kids, take your family, and go see the stars. I can't emphasize that enough. It never gets old.
When we get those links, I will certainly add that to our website, friendsoftheplanetarium.org. And that is one of the places where you can check to find out when our next speakers will be available. And we'll be looking for that near Earth asteroid talk and a number of other things coming up, plus some in-person events where you can do hands-on activities and learn more science across the fields, not just astronomy. We're interested in it all, although astronomy is certainly my first love. Thank you so much for being with us this evening. And as Dr. Seitzer says, go out and take a look at the sky. Maybe not tonight, it's pouring rain, but there are other opportunities, even from Arlington, to see what's above us. Thank you so much, and good night.
All right.